Okay, so hello. My name is Fei Deng. I'm with Verizon. I know we are a bit late on schedule, so I'll try to keep it short. I know Alan has a lot to talk about. Yeah. So anyway, here it goes. What I'll be talking about is the, well, first thing will be the scheduling APIs. Some of you might remember it from last summit, 2018 Fall Summit. So what we did was we had a few new APIs proposed. It's mostly related to scheduling, the continuations, and thread affinity related to where the scheduling will happen. And since then, we've changed the design a little bit, and we've noticed there's some confusions about how the scheduling should go. So I'll be making some updates on that. So what I would do is basically just go over some of the expected behavior of each API. And the first one will be the schedule on pool, because this is the one that has the most confusion. I think mostly it's because this one has quite a few different routes it might take, depending on what the provided arguments are, especially the thread pool argument. So first of all, we need to make sure everyone knows this is true. So the thread affinity will only take effect if and only if the thread affinity is the same as the thread pool, and the thread affinity is stored as a pointer in the continuation. So if you know this, everything should be pretty clear, but I'll go over this anyways. So the first scenario will be there is no thread affinity information in the continuation, and then the thread types are different, and I'll explain what different means here. So as I said, the thread affinity is stored in the continuation, but this one doesn't have anything stored, so it's blank. It's a null pointer, whatever you can think. And the plugin is calling this API on the thread A, and thread A is a ET task thread. And by different types of thread in the scenario title, I mean by the thread A and the thread pool, which the plugin wants to schedule this continuation in, is different, since thread pool here is provided as an ETnet. So with this one, what will happen is the system will see, okay, we have no thread affinity information, so we'll just ignore totally that part. And since we have the thread pool provided as an ETnet, we'll basically just say, okay, we'll pick the next available ETnet thread and schedule the continuation on that one. This is basically the old behavior, but we just changed the name from TS continuation schedule to be on schedule on pool, because the thread pool is provided. The only difference here is, since we added the thread affinity part to the scheduling system, after everything happened, like after the system picked an ETnet thread that's available, that ETnet thread gets stored as a thread affinity in the continuation, because there's currently no information stored for that continuation. So that's the only difference. We'll store the new thread, the ETnet thread, as the thread affinity.
All right, I'm going to bike check because I'm just not a good person. Oh, you broke it. Dang.
Timeout. See?
Nice bike shot.
I totally destroyed it, didn't I? Yeah. The presentation was just gone. Okay, oh, I got one.
Yep.
I wasn't sure you guys actually wanted to hear what I was saying. So this is what the argument set that had originally, right? The continuation, the timeout, and the thread pool. Does it always have to have a timeout, or is that really a time in the future?
It can be zero. It can be, yeah.
What does it actually mean? It doesn't really mean timeout, does it?
It's
It's schedule me in this far in the future, right?
Yeah.
Okay. We should probably clean up the names there
Yeah,
at some point,
we
because
should.
that's really a
another
bad.
thing. Yeah, I'll be talking about here because I.
Oh, okay. And also flip the order of the last two, so it's easy. Well, let's see. You can't make it optional. Never mind. All right.
Which one? Schedule in. Oh, you mean the name? Yeah, yeah.
Yeah, I don't mind that so much. Having the argument name being timeout seems the most
Yeah,
confusing.
I just try to keep the names the
All
same
right.
because people get confused already. So
Go big or go home. All right, let's
okay,
move on.
yeah. So that's the first scenario. The second scenario is quite similar to the first one, except this time we have the same types of threads. So thread A is an ET task, and thread pool is also provided as an ET task thread. So this time, basically, the system says, hey, I'm already on ET task. Why not just schedule it on this current thread? And that's what will actually happen. And the same thing for storing the thread affinity information after scheduling the thing because there's currently nothing stored. So that's scenario 2. And for scenario 3, this one is a bit different than the first two. So this time we have a thread affinity information, and we also have the thread pool provided as a different type as the thread A. So one note here is it doesn't matter which thread the plugin is calling the API from. I'm just trying to keep this simple, but you can definitely say I'm calling this API on thread C, B, whatever. It just has to be the same, different types as the thread pool, and this scenario will basically match. So this time, since we have a thread affinity information, the system will see, okay, I'll check it, but then when it's checking it, it'll see, oops, the thread pool is different, is a different type. So it'll just totally ignore the thread affinity information again and schedule it on whatever available thread there will be as provided as the thread pool type. And then since we already has a thread affinity information in the continuation, it will just not do the store the new thread as a thread affinity that step. We'll just skip that. And there's something I won't talk about this one, but I'll be talking about this later. I'll finish all the scenario explanations, then we'll discuss. And scenario 4 is basically a variation on the scenario 3. So this one is pretty straightforward. We have a thread affinity information. We are on the thread A, and thread A is the same type as thread pool. So basically, the system would just say, yeah, I'll schedule it on the thread A because it's the same type. And we already have that information, and we'll not touch it because we already have it. So that's that's everything about schedule on pool. That's API, and this one is just TS continuation schedule. It will not be available if you don't have a thread affinity information stored.
Is there a return code for that? How do you know?
A return of what?
Well, I call it, and I screwed up. I mean,
yeah,
surely you believe that.
Yeah, I'll return null pointer. And this is another one I want to talk about later in the discussion. So keep that thought. This one is the most straightforward one. You provide a thread, and we'll just schedule on that thread. It doesn't matter what type it is. If you provide it, then we schedule on it. All the documentation of this one? Yes, if you give it that thread, we'll just schedule it on there because you know what you're doing. Like this is like, if you know what you're doing, just then we allow you to do that. So if anything goes wrong, it's your fault. That's another thing I want to talk about because I want to remove something here. Yeah.
Something came in on that one, they just gave us something to equal 32, and all the memory assumptions we made.
Yes.
Yeah. Did you have any background about why we're doing this? Because
Yes, I do
okay,
have
because
it.
yes, it's important to discuss why we want to do this. There's good, and Leif is alluding to those reasons, but I'd like a
Yeah.
more explicit discussion. All right, I'll wait for that.
Uh-huh. And, okay, that's, and don't back up. Okay, don't care. Can I just drag it out of view so we can just buy? So yeah, about that thing. The short version is there's a mailing list email out there. So if you're really interested in that, you can go check it out. But the longer version is remember. Wait, I don't remember who first mentioned it, but you? Okay, yeah. So the question was, can we schedule things on a specific thread and avoid the lock contention problems? And that evolved into having options to schedule on different types and making that jump to the original thread, because that way we can also resolve the lock contention problems. And that is actually this API, because this one was originally there. We just added the information about the thread affinity. So if you have that information, it will use that. If you don't have it, then we'll just keep like the old behavior, just schedule on the next available thread. And
Yeah, I think this all came out of the case from WeAmp filed an issue. There's actually an issue somewhere where all this discussion started. And it evolved into this.
Yeah. And I think the first proposed one was actually this, because we just wanted to have, we know which thread it was on, and we want to be, the next event will be scheduled on that thread, so it will not have problems. And I forgot who suggested, I think it was you actually suggested the thread affinity.
I mean, I happened to suggest it at that time, but the whole thread affinity stuff is something that's been discussed in the community for at least a couple of years before that. We've always said, well, we should probably do this.
Yeah.
And then case was just the trigger to say, okay, let's jump in.
Yeah. So one thing, actually, two things I want to talk about here is, I'm not quite sure this specific one is useful, because like, why do we want to schedule just on that affinity thread and not use the thread pool information? It's kind of like bad.
Like an open pit with bungee spikes at the bottom?
Yeah, something like that. It's like quite similar to the on pool, just not providing the pool information, but then the pool information will actually have like a backup saying if the thread affinity is not there, we can do that. And this just doesn't have that. And it kind of feels like no use.
Yeah, I think if we had more thread pool types, it might actually be useful. Basically, really, you're either on an ETNet thread, or you're on some specialized thing. You're flipping between the two.
Yeah.
And so then this might be handy to say, well, I don't know where you came from, just go back there. But really, the only place you go back to is ETNet.
Yeah, we only have mostly just ETNet, ETTask, and
well, it's ETNet or something else.
Something else, yeah. Yeah. So I'm thinking about just removing this one and.
Yeah, it's not that much hassle to have someone just put in the pool, because really, you should know what pool you're sending it back to.
Yeah. Yeah, we can do that. But the on-pool one is basically because we have this, so we have to name it something else, right? Yeah. And then this will become just like the old schedule, and then we just have a special one for the on thread, because if you have a thread and just really want to do that.
Yeah, I mean, sometimes you really just want to say this is if you're doing coordination between different continuations.
Yeah.
Because you can pull the affinity, the affine thread out of an existing continuation, right?
Yeah.
So this would be nice to say, okay, I've got this other continuation. I want to make sure this one goes there.
Yeah. So, well, we can talk about that later. And another thing actually is about this one. It's actually about the thread affinity information. Someone, I think it was OKNet or on one of the PRs you mentioned something, but like when we designed it, we talked about having a hash map of some kind, having each type have a thread affinity, and then we decided not to do that. So it's going back and forth on that thought, because sometimes it seems useful and sometimes it doesn't seem useful. Most of the time it's not, because we will not have that many affinity things to jump back to. It just doesn't feel right. But sometimes, like if you really want to have a thing just jumping back and forth on two threads, there's a special use case.
Yeah, I think that's too obscure to put into the core. I mean, you can always simulate it by putting your own affinity stuff in the continuation.
Yeah.
Right? I mean, we put it in, we move, because that's the way a lot of pieces, like I know the cache did it, and there's some other pieces did it by, they would explicitly record this. And when that was common enough that we said, no, the core should just directly support it.
Yeah.
But the 2 case, I think, is just not, it's too rare to make everyone pay the,
Yeah, exactly.
the price of that.
So, yeah. Mm-hmm. Yeah, exactly. So, so yeah, I think we'll just keep it like this for now. So I guess that's everything about the thread, affinity, and scheduling stuff.
And Faye loves to talk about it. So this afternoon, if you want to get in deep, grab him.
Yeah. I'll try to hide. So another thing here I want to talk about is the thread startups and shutdowns, because recently we've been seeing quite a few weird crashes related to shutting down the system, and we added a lifecycle hook to try to fix that, and that actually helped with the plugins, but it didn't really help with the whole picture, because most of the time when things go bad during shutdown, it's because something went out of order, and say thread A is going to shut down, but it's depending on something on a different thread, but the order messed up, and just things go awkward and just breaks things. So this is what we have right now. So we catch the signal, most likely will be I think SIG term or the SIG interrupt, and then we just schedule a continuation with a delay or immediately, depending on the configuration, and that goes to one of the event threads, and then that will handle the continuation event and invoke the lifecycle hook we added, and then after that we'll flag, we set the flag for termination of the event loops. So there's quite a few things I don't really like about this, but I'll keep talking about other stuff, and then we'll come back to that. There's three problems here I can think of right now. The first one is handling the shutdown as a trigger, as a continuation, and then that means it happens on an event thread, and since we're terminating event threads on the event thread, just doesn't seem right. So the next thing is different parts of the system don't know like what's going on. It just happens, and we hope things go right. So that's another thing I don't really like. And then since we added the lifecycle hooks, I think we are the only one that is using that, so it's fine right now. But when we were testing that, sometimes things go longer than expected, and that actually breaks stuff quite a bit.
Oh, so by timely, you mean that the hooks take a long time to execute, not that they get called at a random time.
Yeah.
Okay.
Yeah. So if it takes, say, a few seconds, then because we are on the event loop, event thread, that thread things are hanging and it tries to kill itself. And then since this is the thread that's handling all the killing of other threads, it's just that goes bonkers. So. So this is what I want to have as a shutdown system. And I could talk. Jason mentioned this. We talked about this back.
Couldn't you use the main thread? It doesn't really do anything now.
Yeah, we can actually do that. This is just like a thought, so we can talk about this later. But the first step is always just catch a signal, and then we can either just make a new thread to handle everything, or we can just put it on the main thread. But I think why did I have this here?
Yeah, the main thread used to get repurposed as an 18F, but I think Phil changed it, so now it just kind of sleeps.
Just sleeps there. Yeah, yeah. We can actually do that. So anyway, it'll be basically just a dedicated thread. It doesn't matter if it's spawned or we already have one. And then we can add the delay if we really want to. So this time, when we invoke the lifecycle hooks, we don't really care if it takes forever or, well, it can't really take forever, but like if it takes longer than expected, it will not hand the whole system because it's not on the event thread anymore. So the system will not think something bad is going on that event thread and try to kill it, and just kills everything else and breaks stuff. So now we can just have the lifecycle hook handled as we intended to, and then we can like have a predefined sequence of shutting down all the other threads and have things go happy.
Have you looked at condition vars for that instead of a sleep or delay?
The sleep or delay, that depends on the configuration, right? Because we have a shutdown delay thing.
Well, no, I meant use a condition var rather than saying, well,
Oh,
no.
yeah. Yep. Yeah, yeah, condition variable works. Actually works pretty good. We have tested that.
Yeah, well, with Affinity, they're just so much easier to use now.
Yeah. So anyone else has thoughts or like happen?
Please, someone else.
Yeah. Does anyone have any like inputs on this? Because like this seems to be happening more and more now. Like the crashes during shutdown.
Where are you seeing crashes during shutdown?
All kinds of weird places. Like we've seen in what's that called? I think do IO block accept? Wait.
Oh, yes, the accept crashes.
Yeah, that one is like, for some reason, the virtual function is not set to virtual or something related. Yeah, that one. Yeah. Yeah. I kind of have a workaround for that, and that's already in master right now. But it's not a fix. It's just a mitigation, because I pointed that to a null pointer. No, I returned a null pointer for one of the stuff, and we check for null pointer now, and that will just say, okay, if it's a null pointer, we don't do anything because that means the system is shutting down. But that's not what it's supposed to do, like, because it's I forgot which one was a virtual function, but it's not supposed to do the stuff it was doing, and I still can't figure out why, because I tracked all the
Well, I thought our theory was that the net accept object is being deconstructed while it's still in the middle of virtual call, so when it...
Yeah.
It's been happening for years when we switched over to go ahead and do the virtual access.
Yeah.
And then set the whole variable, but it should. I thought all that was resolved.
No.
Are you testing on, you're testing on 7.1 now?
7.1. Yeah. But if I'm doing my personal test, it's on master, open source master actually. Like we see that in the production, that's the 7.1, but then if I test it the same on my my test environment, that's master.
Because we used to get it when we would run like regression tests and stuff like that.
Yeah.
All that result.
Yeah.
I don't see that anymore in the regression tests.
Yeah, that one is actually doing fine. But in production, we have it's still happening. So, but anyway, having a better shutdown way is, I think, it's useful. So,
Yeah, some of it may be due that we use a lot more standard strings as static data structures.
the what?
Standard string, right? So if you have that as a
yeah.
static data structure and those are getting destructed in the middle of other activity, then they explode pretty easily.
Yeah. So, I think, yep, that's, I think I still have a little bit here. Nope, don't have anything more about that, but yeah, we can think about this, and if we want to work on that, I'll be happy to help. So, yep. Oh, okay. This is pretty short. So jemalloc stuff. We did quite a bit of testing recently, but this is like the old data. So we run jemalloc and freelist versions of the system on 17, 18 boxes each, and then this is like the moderate load differences. So without the freelist, we have about 1.92% increase in CPU utilization, and the memory utilization is about 0.07% more, and that's normalized to RPS. So that looks actually pretty good, but then when we did the stress test last week, we found jemalloc versions are running quite badly, I would say, right? So, but we don't really know what's causing it right now. It just have a lot of lock contention problems happening, but it's not happening on the jemalloc side. It's, I forgot. Susan has a name for that.
I thought it was in the jemalloc futexes.
Yeah, it's on the jemalloc box, but the trilock happening on inside the jemalloc is not. Huh. Susan has it on NetDB actually, I think. Okay. Yeah, but so it's kind of like we don't really know what's going on, so we need to do some more tests. But on moderate load, looks pretty good. Doesn't really say it's increasing or decreasing because this is really minor differences. And the request per second is basically the same, like 10, 13 differences. Yeah, so we'll be doing more tests on that, and eventually we'll be able to figure out what's actually causing the lock problems. And we'll be actually testing tuning the jemalloc with different options. I think Susan wanted to test the thread caching flag, and there are some other flags I've kind of forgot, but there are a few options we can try and figure out. And Leif yesterday mentioned keeping freelist because you're seeing what was it? For some debugging, kind of forgot the name, right?
Yeah, so I use the freelist feature is nice in that it isolates. So how do I explain this? A lot of the freelist stuff is expected allocations.
Yeah.
When we introduce new code, there's been plenty of cases where we introduce new and malloc in undesirable ways. And it's really hard to debug that without having the freelist, because if everything becomes a malloc or new, you can't distinguish those rogue mallocs and new from the ones that happens on the previous freelist, right?
Yeah.
So keeping the IO buffers and keeping the HTTPSM and those things on the free list makes it possible to debug or analyze the critical path for these events where we do unnecessary mallocs and news.
Yeah, I know Jason's also often talked about looking at doing using the STL allocators to do some of this, so that even though you do new and free, it's actually going through a free list mechanism under the hood, and then you would still have this tracking. The question is, what benefits do you get from that? I mean, either you're doing block allocations when you need more memory, in which case it's really hard to release that stuff back to the OS. Although maybe it's worth it if we just cache them, right? Just say, well, we're going to do alloc fundamentally for every object that we have, but we cache them on the thread local, so after a while you stop allocating new objects, and then they're easy to free back. Because the whole point we started this, right, was that we were having fungibility problems with memory.
Well, so in my case, I was just curious to see what we had done on the critical path when it came to memory allocation. And it's not obvious looking at the code what happens, right? So in one particular case, we were using an API in librecords that's sort of a few levels further deep down in these APIs ended up calling ATS malloc. And then when you sort of unroll that, when you discover that, you unroll, well, this is not the right API to use in this place. There are better APIs to use which do not have memory allocations. And those are the sort of things that are really difficult to just looking at the code review. There's nothing in the patch that does malloc or new, but by using this undesirable API, the wrong API, it ended up causing 2 mallocs actually on the critical path for every request. And as we discussed before, not doing malloc is always going to be better than doing malloc, no matter what's underneath in the memory management, right? So, and when we have cases where we start adding these new patches and these new codes, where it's not obvious that we're adding memory allocations, it's really difficult to debug, and it's hard to measure the performance implications, right, until it becomes a real problem. But you accumulate too much of that, it gets problematic. So I like a way to have some sort of debugability where we can see what's going on with memory management on the critical path.
I think if you're going to do that, we're going to have to do some stuff you even hate even more, which is some clever templating so that it's easier to do this. Because I don't want to see 500 different allocators that everyone has to pound include in some header file, because that doesn't seem sustainable either. You'd like to be able to do that in some cleaner way.
No, that's not what I'm saying.
No, but it's an implication. It follows from that.
No, what I'm saying is the way I debugged this was to say, in ATS_malloc, put a breakpoint.
Okay.
And then you run the system and you do a request through it. If it trips ATS malloc, I know something is broken. And then I backtrack from there to see where this malloc actually happened. But if everything becomes essentially an ATS malloc, which is what happens, right, when you do when you get rid of free list, then you obviously can't break an ATS_malloc. Right. So that we talked about them, Ian and Faye. We talked about maybe we can split things up, memory arenas or something where you can say IO buffers goes in one memory arena, the current free list stuff, the non-IO buffers goes in a different arena, and then everything else, malloc and new, goes to this third arena.
Yeah, I don't know. I've seen some of the output from the jemalloc debugging, and it can. I know Sue's actually tracked down a number of leaks that way. Where you can just see the sync and say, "Oh, wow, this line right here is allocating on this memory and not freeing it."
Yeah.
No, I'm not against. I mean, we need to get more numbers too, right? I'm just pointing out that it's useful. It's been useful to have that option of saying stop tracking. I don't want to see memory allocation that happens on the free list stuff, because I know that's fine, but I do want to see what's happening with ATS, the mallocs and news, right?
Yeah, I think you should look at the jemalloc diagnostic, because it'd be interesting. Oh, you could make Faye do it, because he's not busy, and be able to say, okay, well, I'm going to fire up traffic server, and then I'm going to start doing the jemalloc monitoring, and I'm going to run 100 requests through. And then I can ask, well, how many mallocs were done, and where were they done? Then you could see, and actually better than what you were talking about, where actually this stuff is going on.
Except the fact that there's a ton of allocations happening in the free list, and it gets hard to distinguish those two that happen, right?
And you start and stop the monitoring, could you run it, say, do 2,000 or so transactions, and then do another 100 with the monitoring on at that point? Right, so what you'd want to do is run a large number of transactions through to get to a steady state, and then say, okay, now I'm going to track the next 100.
Yeah.
You could be doing thread local stuff, or it could be doing,
Yeah.
going ahead and doing the local. They could be doing whatever. You don't really have as much. And I don't know if there's ways to go ahead and check that.
I know.
I'm not I've always been a proponent of jemalloc. I think it's great, but I'm just pointing out that that particular use case has been useful in finding really bad code.
And I've seen other people, we ran into try locking went up to the most expensive thing on the box when we were benchmarking it. But it was that, also news and freeze were taking course to our CPU. And I've read that other people have problems with TriLock. So I don't know. We're going to flip off the box and double check to make sure that there's nothing weird about that box.
Yeah.
Which I think is a good idea.
Yeah.
But we'll see.
Mm-hmm.
It's only when you get a busy system.
Yeah, like,
And we're pushing it as hard. We're pushing it like 70, 75, 80%.
yeah. Most of the time, like this is just fine, I think. Yeah. So.
To be blunt, those numbers are not particularly, I wouldn't even call them moderate, this is pretty light, low
Yeah.
comparison.
Yeah.
The most concerning thing I think when we were doing heavy was latency increase and TriLock.
Yeah, TriLocks.
We're starting to hit like another bottleneck. I mean, we just got rid of the OpenSSL lock contention. Now here we're going in and throwing in jemalloc, and now we're going to have another lock.
How much network bandwidth of this guy is if you do it 4,000 requests per second?
Oh, I didn't check on that one.
Those events where you're reading from this, turning into IO buffers, you also cause you to run into jemalloc contention, right?
Yeah.
So if you're doing stuff, if this is only stored on a RAM cache, then you're not really exercising a lot of the jemalloc stuff that you're doing. If maybe a box is doing up to a gigabyte per second, isn't it?
Mm-hmm. Yeah.
And that's a lot of memory to allocate into IO buffers.
Yeah.
We did in Pro, we couldn't handle it.
Yeah.
What version of jemalloc?
Latest 5.1 something, I think. Yeah.
So we definitely want to do tests too, and we're having other issues now around 803, 804 and whatnot, so we're focusing on, Miles is shooting himself. But as that settles down in 2022, then we'll probably start doing more randomness to look into jemalloc 5 and those things.
Yeah.
We get some benchmarks. Like we have boxes doing up to 80 gigabits, and I don't know exactly what percentage of that is off disk, but significant amount of iBuffer
Yeah.
going in and out of jemalloc.
Yeah. We actually have a new testing system on the work right now. So if that actually works, it'll be a lot easier to test like big loads and stuff.
I
Yeah.
think it's important that we look at some of the, I think iBuffers were one of the bigger ones that was in out of freelist,
Yeah.
and you need to make sure that we exercise that.
Yeah. I still have the.
Even RAM cache only.
Yeah.
If you're 99% RAM cache ratio, you're not exercising much.
Yeah. I have the data. I just didn't check it and put it here. But yeah, I'll check when I go back. Yep. That's it. Thanks.